Hi guys. So in this video, we're going to learn about rates of change and related rates. So this is lesson number 9. So when we're doing rates of change, there's certain types of rates that we need to look at in the real world, especially application to physics. Example, we're looking at S of t function, right? Which is the displacement, right? So if you're looking at the displacement function, displacement of a particle or moving car, right? Displacement, or sometimes called distance, if you're taking the absolute of it, right? Displacement. If you're finding the derivative of S prime t, right? We get V of t. V of t is velocity, or in loose term, it is speed. Remember, displacement, velocity are vectors. It has direction. Distance and speed are scalars. And now if you find S double prime t is the same thing as saying V prime t. If you find the rate of change in velocity, that will give you the acceleration A of t. So that's the acceleration. Okay, now let's take an example and work with it. And similarly, in financial maths, we get the cost function, right? C of x is like cost function. Now, what's a cost function? How much does it cost to produce a product or to buy a product with certain quantity? So we say x is a quantity and c is this cost function. If you find the derivative, right, you get the rate of change of cost. So what does that represent? We will learn at a later stage. What does the derivative represent? Is the rate of change, okay, of cost function. That means what is the cost of producing one additional product, okay? So looking at something like production cost, more like production cost. We will look into that by means of an example. So let's look at example 1. Right, so there's a lot of questions here. So let's take a few questions at a time and work with that. So see what it says. The position of a particle is given by the equation. So that's a position function. In other words, the particle is in motion as we increase time. So the position of a particle is given by the equation. So this is some kind of a function, all right? So it's moving in this direction, like a cubic function, all right? That's the pattern of a general cubic function from pre-calculus, okay? Because the value of a is positive. And you know, like how you have quadratic function patterns, this is a general pattern of a cubic function. That's how it's moving. Now we're looking at where t is measured in seconds and s in meters. So meters per second, right? That's velocity. This is the displacement function, which is the position. Position means the displacement. Find the velocity at time t. Very simple. We have a
Find the
polynomial
velocity, we
function.
have to find the derivative, right?
Correct. So let's find the derivative. So v of t is the same thing as saying s prime t. You can say s prime t or you can say f prime t because s is measured in terms of the function f. They called that. So you find the f prime t. Good. And f prime t is equal to 3t squared minus 12t plus 9. Find the velocity at time t. So this is the velocity at time t. It's a function. B, see what they asked for, velocity after 2 seconds. What's the velocity after 2 seconds and after 4 seconds? So what's the velocity after 2 seconds? Let's write it down. So that is v of 2. If you substitute 2 inside, you're getting, guys, need some answers from the calculator obviously you guys are much faster in calculating this. So that's 3 times 4. 3 times 4 minus 12 times 4, 12 times 2 plus 9.
Negative
It's,
3.
it's negative 3. It's
But you forgot the
negative
power
3.
4.
Yeah, multiplied by 4. 3 times 4. Is that correct? 3 meters per second. Correct? You have to write down units of measurement because it's velocity. 3 meters per
Mr.
second. Yes.
If he
Yes.
wants the acceleration, do we find the second derivative or do we just find the derivative of the velocity?
It's the same thing as saying find the second derivative of the f prime function.
So
If you-
technically we derive the velocity.
Yes.
Okay.
Right, someone had a question? Yes.
Hold on. What was I going to say? Sorry, I forgot. Oh yeah, didn't you say we were going to do applications of derivatives?
That's what we are doing now. We're doing application of derivatives. To find it's a displacement. If you're finding the derivative of displacement function, you're getting velocity. Derivative of velocity is acceleration, which is the same thing as saying double prime. We are doing application. Then we have the cost function later on that we're going to work with. Then after that, remember, this is just to introduce the topic. The main topic of here is related rates. That's where we're going to do some difficult differentiation and stuff. Right, so we found V of 2 means negative 3 meters per second, right? In other words, there's like a direction change here, isn't? It changed direction, correct? What about next one? V of 4. Substitute V of 4, you're going to substitute into the derivative function. So that's 3 times 16. 3 times 16. V of 4. Or let's just say 4
It's 9,
squared.
mister.
Yeah, 9.
Multiplied by 4.
The
We're getting
48
9.
cancels out, we get 9. Yeah.
9 meters per second. Right, so we got what is the velocity after 2 seconds and after 4 seconds? That's what the velocity is. Right, now let's continue with the rest of the questions, yeah? I didn't want to write out all the question one time, then it's too much, right? Let's look at the next question, next 2 questions, right? Do 2 questions at a time. When is the particle at rest? Think about the car when you're driving. When will you come to rest?
At t equals 0.
No, when will the car come to rest? You are moving in the car.
Oh, acceleration is 0.
So when V of t equals 0.
No, when the velocity is
Yeah.
0.
When
you're
velocity,
not-
when V of t is 0.
When you don't have speed, then
Yeah.
you stop. Yeah, so you
So
park.
this,
After 1
this
second.
function, 3t squared minus 12t plus 9 equals 0.
Excellent. Good stuff. So C, whenever something comes to rest, it means the velocity V of t must be equal to 0. So V of t is 3t squared minus 12t plus 9 is equal to 0. Look, acceleration of 0 means your car is still moving. You just that you're not accelerating anything, okay? It's like on cruise control. You're not accelerating, but you are still moving. You get it?
Yeah.
Are we good? Yeah. So
Yeah.
when you say velocity is 0, you're not moving at all. Like the car has 0 speed or 0 velocity. That's why we're saying V of t equals 0. Right, excellent. So now we can go in. Yes.
I put this in my calculator and I got x equals 1 and x equals 3.
So you're going to change the x variable to time t variable, okay? So look, this is what you're supposed to do. Don't go and factor it out like this. Put t squared minus 4t plus 3 equals 0. Because remember, we can factor out a 3. In other words, you're dividing by 3 the entire equation. Try to simplify the equation, then you can see the factors. Factors of 3 is 1 and 3. So t minus 1, t minus 3 is equal to 0. So in other words, t is equal to 1 second. After 1 second, the particle comes to rest, okay? And after, t is equal to 3 seconds. Make sense? So when is a particle moving, sorry, when is a particle at rest? In other words, it's like a horizontal tangent. Remember what I was telling you? the general structure of that particle moving is given by this. So basically it's coming to rest at this point, right? Maybe taking a U-turn or something. Let's check. Just carry on with this
So,
problem.
Mr.
Yeah.
Basically, when a particle is at rest, is that a point of tangency?
Yes, horizontal tangent. Okay. Next one. When is a particle moving forward? When is a particle moving forward? That is in the positive direction. So what we are looking for is, because they said positive direction, when is a particle moving forward? So we're looking at we're looking at the speed being positive, all right? So we're looking at v of t is basically greater than 0, because we're looking at positive. And obviously we can draw a diagram and get both the positive and the negative. So we need to go and say 3t squared minus 12t plus 9 is greater than 0. Okay. Now, if we solve this, we're going to get t squared minus 4t plus 3 is greater than 0. So t minus 1, t minus 3 is greater than 0. Now, how do you solve this inequality? We draw a number line. Okay. There are two critical values on the number line, which is 1 and 3. Okay. So between 1 and 3, what's happening? If I substitute any value between 1 and 3, remember, we can't continue forever because time starts at 0. Remember, this is a time function. Time has to be 0. Okay. So you can't continue forever infinitely. Can't be negative because this is we're finding values of t. Time can't be negative. So choose any value between 1 and 3, like the number 2. If I substitute 2 here, I'll get 2 minus 1 and 2 minus 3, positive and negative. So I get a negative, right? Between 0 and 1, maybe I can substitute half and half. So I get negative, negative. So that's positive. And after 3, substitute the value, any value after 3, like 10, positive, positive. So positive. Okay. So if you get one of the signs, and if these are linear factors, then you can alternate them. Only if they are linear, both the factors are linear, then I can alternate them as long as I find one of the signs. So when is this moving in the positive direction? The direction is positive. So you're going to say positive direction is when t is an element from 0 to 1. Okay. Or from 3 to infinity. Okay. It's moving in the positive direction. And negative direction, you know what positive direction is? Remember, this is city A and this is city B. So this is going positive direction. Negative direction means like you kind of like returning. Okay. Or you're coming back to somewhere and then going back. So that's what it means, positive and negative, because of vectors here. Right, so now when is it negative direction? It is between 1 and 3. The idea is to solve for the inequality. Are we good, guys?
Yeah, Mr. I have a question. For
Yeah.
negative direction, we're not including 1 and 3 in the domain, are we?
We can't include it because at 1 and 3,
Because it'll
is
make it
rest.
0.
Yeah, it is at
It's
rest.
Okay, I
Yeah,
see.
that's the reason why. Yeah.
Zazali,
Yes.
is acceleration a vector as well?
Yeah. Acceleration is, example, you have gravitational acceleration. It's 9.8 meters per second squared downwards. Isn't that a vector? Because you gave it a direction and a magnitude. Okay.
Okay, thank you.
Yeah. Obviously, gravitational acceleration on different planets have different magnitude. Yeah, so that was Nice question. All right, let's continue with this. See what we can solve. So we want to draw a diagram to represent the motion of the particle, okay?
Mr. Does that mean a graph?
Not a graph. I mean, a diagram like representing time and, distance. Yeah, it's kind of like a graph, but
Like a
To
plot graph, plotting.
you can, but we don't need to do the exact draw diagram to represent the motion of the particle, right? So let's see. I kind of drew it here, but let's draw a diagram like this. Let's put it on the x-axis, like just to describe what we are talking about here, right? So I'll start at 0. Time starts at 0, right? Which is E. Okay. And then, so we're looking at displacement time graph, because this is the motion of how is this particle moving. So we got 0, right? What other values we have here? No, man, we can draw a graph like this. It's fine, but how are we going to, isn't we need x-intercepts and stuff? Okay, put this function into the calculator, t cubed minus 6t squared plus 9t, and see if we're getting any t values. What it was, s of t
Sir,
equals
when it
0.
asks for motion, what does that mean? Does that mean velocity or does that mean the
No.
the original function?
The original function.
Okay.
Draw a diagram to represent the motion of the particle,
Yeah, okay.
right? It means the original path that the particle takes. The position of the particle is given by the equation. Right, so s of t is equal to t cubed. What is it? T cubed minus 6t squared plus 9t is equal to 0. So we got t into t squared minus 6t plus 9 is equal to 0. So we got t equals 0. Sorry, we need to factor out the entire thing. T into t minus 3 is equal to 0, okay? So t is equal to 0 and t is equal to 3, not and, O. Are we good? So let's draw a graph like this then. Lisa, are you there? Understanding?
Yes, easy.
It's easy so far, right? So this is S of t, or you can call
I'm waiting
it,
for optimization, mister.
F of. I'm doing related rates today. I need you to understand that, because that related rates has implicit differentiation there. Remember this place over here, if time is 0, then where did the particle start off? If 0 time, so the particle, what is S of 0? Time 0, S of 0 is also 0, okay? So time is 0, S is equal to 0. There was no movement. Then the particle started moving, all right? And it reached a maximum of some point. So t equals 0 and t equals 3. And we have t is equal to 3 here as well, right? T is equal to 0 and then t is equal to 3. And then what happened? Isn't we found this 1 and 3? So we found 1 and 3. 1 is somewhere around here. If I substitute s of 1 inside this function, what is s of 1? If I put 1
So
inside
it's
here,
it's -2. Yeah, -2.
s of 1. Wait, no,
S of 1.
not negative 2.
Yeah,
S of
The
1
top
is
the
function,
negative
the
2.
top function.
it's 1
No,
times
no.
1 minus 3.
No, no, not that one, not that one. Sorry.
That's the derivative.
Uh,
That's
It's
the
4.
velocity
Would
one.
equal 4 if you put in.
No, no, no. I want
can't.
f of 1. S of 1, S of 1. I want
S
1
of
here.
1.
So 10,
1
yeah,
there.
it's gonna be 4.
10.
4. It's gonna be
Yeah,
4.
1.
Right, good. S of
Yeah.
1 is 4. So S of 1 is 4, right? So we can see that the particle is moving like this, right? Then coming down, and it got is coming down, sorry. S of 1 is 4, 1 is here, right? So the particle is moving up, right? Then it comes down to 3, and then from 3 it doesn't go beyond that, right? And it goes up. Okay, so you can see the increase and the decrease. The increase is from 0 to 1, then 1 to 3, okay? And from 3 it changes direction. You understand? First it was going in the forward motion. So if I explain this in terms of like 2 points, like in terms of a diagram, this is what it's doing. So what is this particle doing at 0? At time equals 0, we know S is equal to 0, okay? So the particle is moving to 1 and then to 3, right? There's 3 here as well. So the particle moves in this direction, okay? Makes sense. The particle moved in this direction. 1 second. Then it turned, it moved in the negative direction, okay? Makes sense. See,
Yeah.
it went forward, then it turned. It's like going back. And then it turned again and moved away, went in this direction. Are we good?
Yeah, we're good.
Because over here, S is equal to 0. Where is S equal to 0? S is equal to 0 at, this is the point 1 and 4. The value is 1 and 4. I kind of like reverse the cubic function. See what I did? So I'm looking at like, so you can make sense of it, all right? Are we good? T at T is equal to 1. Remember, this is time T. At T is equal to 1, S is equal to 4. Okay, so it's kind of like the particle traveled 4 meters after 1 second, right? Then it changed direction and it traveled back, right? So it went back to 0, okay? When did it go back to 0? When time was 3 and the displacement became 0. See, so we're talking about this point here, it went back to 0. And then after 3, it went back up. So I don't think you should put 3 here. I think you're getting confused here there. Yeah, because this is that actual time traveled. So this is the particle travel for 1 second, then when it reverse direction, it traveled for like another 2 seconds, and then from there, it went back in the forward direction. Are we good, guys?
Yeah.
Does that make sense?
Yeah.
Just remember, every increase and decrease on the f of t or the s of t function is basically changing direction. Let's look at the next question. Find the total distance traveled by the particle during the first 5 seconds. During the first 5 seconds, okay? I want the total distance traveled. Make sense? How are we going to get that?
Put a 5, like switch T for 5.
Okay. So because we want the total distance traveled, how are you going to get the total distance traveled? Because now this particle is changing course. So you have to go from 0. You need to find S0, which is 0. Then you need to find S of 1. What you see is an understanding question because it's physics. You want the distance, not the displacement. Right? So S of 0 is 0, S of 1, you have to take every single point on this graph to see what is happening with the particle. So S of 1 is 4. So between time 0 and time 1, the particle traveled 4 meters, right? S of 1 minus S of 0 is 4 meters. Are we good? So now we know after 1 second is 4 meters. Now after 3 seconds is how long? So now I need to find S of 3. What is S of 3? We can clearly see it is 0. So this implies it's absolute value though, right? So it doesn't matter how you write it, 0 or 1. So S of 0 minus S of 1, because it's absolute value. So now we're saying S of 1 minus S of 3. That's
Why did
also
we
4
skip
meters. Because remember, it changed direction. Watch here. From time 0 to time 1, the particle traveled 4 meters, correct? And then from time 1 to time 1 to time 3, the particle traveled another 4 meters. You understand? So 2 is not even in the picture. Don't care what's happening in between.
Okay.
Are we good? Yeah.
Yeah.
2 is not intercept, or neither is a critical value. And then now we're looking at after 3 is changing direction again. So we're going to put S5. So if you put 5 in the original function, what do you get? 5 cubed 125 minus 6 times 5
You have
squared
20, Mr.
plus 9 times 5. Do you get 20?
Yes.
So I got yeah 20.
So now you're going to say S of 5 minus, this is S of 5, S5 minus S3. What is S5 minus S3? S5 is 20 minus 0, correct? So you're getting 20 meters. So what's the total distance traveled?
28.
Wait, mister,
Yeah.
are we supposed to also count the distance traveled from, let's say, from S of 3 to S from S of 1 to S of 3, which is also 4 meters? So we're counting from like
yeah,
from 0 to
So from
4 and then back to 0 and then like we're
yeah,
counting
then
each
after that
step,
is
aren't we?
yeah. We don't need
So-
we don't need 2.
Because I got
Why do you need 2?
2 where? No, I didn't say 2. I said
Okay.
S of, so we go from S of 0 to S of 1 and then S of 1 to S of
That's
3.
4 meters. That's 4 meters. And then from 3
Yeah.
till 5 is 20 meters.
No, but then we also count like from 1 to 3 and then 3 to 5 is more than that, is it? Because I counted S
No.
of 4 as well.
No, you don't need S of 4.
No?
Why are you calculating S of 4? We don't need S of 4. Because the next point, the stop is at 5. So you need to find S of
Yeah.
5.
No,
Yeah,
because I
so it's
added, so
28
okay,
meters.
it doesn't matter. Yeah, okay. Okay,
S
yeah.
of 4 and S of 2 is insignificant. There
Insignificant.
is no
Okay.
S of, S of 2 and S of 4 are insignificant. We just need from 0 to 1, 1 to 3, 3 to 5.
Okay, I see. And then we
Okay.
add everything up.
Yeah, because it's
Okay,
like
I see.
your odometer reading, the reading counter on
Yeah,
your
yeah,
car.
exactly.
So
Yeah, okay.
that's, does that make sense? Right,
Yes,
excellent, guys.
yes, it does.
Last question. I hope this is our last question, right? All right, I'm not going to graph these things. I'm looking at G here now. Find the acceleration at time t, right? Acceleration at time t after 4 seconds. So what is the acceleration? So we need to find the double derivative, right? So did we have the single derivative, which is a velocity function is a single derivative, right? So let's find that. There's this, I'm just going to copy this part here because we're looking for acceleration, right? So we have the velocity function, right? If I find the derivative of the velocity, it's the same thing as saying f double prime t, which is the same thing as saying acceleration, a of t. So what's the acceleration here? 6 times t, 6t minus 12. Right. So what is the acceleration after 4 seconds? If I put 4 here, you can say a of 4. That's 24 minus, so that's 12 meters per second squared. Makes sense? That's the reason why this is not constant. You see? So from a particle moved from 0 to 1. In 1 second, it moved 4 meters. Then another 2 seconds, moved 3 meters. So what's happening after you take a turn here? This thing is just accelerating. So that's the reason why over here you got 12 meters per second squared after 4 seconds. That's the reason why the value, you have such a high value. After you turn at 3, you got such a high value, 20, because it is accelerating. Make sense?
Yes.
When you accelerate,
Mr.
you reach
I have
a
a question.
faster. Yes.
I understand everything, but my question is, why when we want to find the acceleration, we have to obtain the derivative, the second derivative? Why? I
Because,
know that we're supposed to do it, but I
okay.
want to understand why.
Okay. Think about the car when you're driving. You're on cruise control, all right? When you press the accelerator, what happens? You're changing the speed. So it's a change in speed divided by a change in time. You understand?
Again?
So what does, see, when you press the accelerator in your car,
Yeah.
right? You are on
Yeah.
cruise control. Now you're feeling bored. So what you do is you start pressing the accelerator. So what are you doing? You are basically increasing the speed with respect to time. So it is dv dt. You get it?
Kind of.
Or velocity with time.
Yeah,
You
you're
mean that?
changing your velocity with respect to time. Exactly. So you're finding dv dt. dv dt is acceleration. You understand?
So it's like you are accelerating, so you're changing time, which is acceleration with respect to velocity.
No, you're changing the velocity with respect to time. And if you brake, you're kind of like decelerating, correct? Like if you leave your
Oh.
accelerator and when you brake, you kind of like decelerating. So you're still changing the velocity with respect to time. That's the reason why we find double derivative. All right, look here, guys. I'm not going to sketch these 3 graphs because look, the graphs of the next question asks us to sketch all 3 graphs on the same system of axes. Graph the position, velocity, and acceleration functions from 0 to 5. When is a particle speeding up? When is it slowing down? What does speeding up mean? I like this question. Yeah.
Acceleration.
Accelerating.
Yes. Yes. When is a particles accelerating and decelerating? Right. So the other graph was graphing all 3 functions on the same graph, which I'm not going to do. Right. So let's look at this. When is a particle speeding up? So you're looking at a of t is being positive. What is a of t? A of t is 60 minus 12, right? Then take this 12 over divide by 6, so t is greater than 2. So after 2 seconds, okay? After 2 seconds, the particle is speeding up. When is it slowing down? Slowing
Can you
down
put the
when
sign?
a of t, just be careful because when you say a of t is less than 0, remember you have a restriction with respect to time. It has to be, watch how you're solving it, is from 0. So, after 2 seconds, what's happening? It is positive. Acceleration is positive. It is speeding up. And what's happening between 0 and 2? So you're going to get an answer which is less than 2, but you'll have a problem. You can't keep the answer like that. So you're going to say 6t minus 12 is less than 0. And it says t is less than 2, but you can't say less than 2 because you have a restriction, it's time. I can't say the value of t is -1. Of course you can't. So that's why I say from 0 to 2. So what's happening from 0 to 2? It is slowing down. Between 0 and 2,
It can be
It is-
negative, right? Acceleration can be negative.
negative acceleration means deceleration. It means it's like you are dropping the speed. That's what
Yes,
he's
yes,
saying.
I understand. But here, why did you say is less than 0? Why not t is just
Because
less
it's
than
slowing
2?
down. Because it's slowing down. You can't say you can't just say t less than 2 because time can't be negative.
Yeah, so
This is-
technically time can be negative, which means the acceleration can't be negative.
Yo, time can't be negative.
Okay.
It means that which is -1. The particle started at time 0. You can't go beyond time 0 now. You can't go say
Yes,
t
yes,
equals
I know,
negative
I
1
know.
second. That doesn't make sense. Yeah, so there is between 0 and 2, the particle is decelerating, and after 2 seconds, the particle is accelerating. In other words,
So, I'm
there was
understanding.
like a change over here. In other words, there was a change over here. There was a change in acceleration at just that 0.2, and now it is significant because of the acceleration. Okay. Right,
Yes, I
guys,
get
one.
it.
I want to do one. Yeah, I want to do one more cost function or whatever. Right, so this is a little bit more in detail. Now let's look at something in economics, right? Moving on to the next question, question 2. All right, so looking at the cost function of a certain commodity is given by this, right? We want to find C prime 100, okay? What does C prime 100 mean? So find and interpret C prime 100. So this is our second question. Oh, sorry, C prime Q first. C prime Q. By the way, you see this cost function. In the cost function, there's something called, see this one here. If the value of Q is 0, what does that mean? What does the value of Q? Yeah, let me explain the cost function first, right? If the value of Q is 0, what's the answer? I got 84. In other words, basically, let's just say 84 is in dollars. Just say the cost function, the values are in dollars. Okay?
Mr.
I'm
Aren't you
putting
supposed
Z,
to obtain the derivative first?
no, I'm not finding the derivative. I'm explaining what does C of 0 mean. I'm going to find
So
the
C of
derivative.
0 is like operation costs without
Yes,
producing labor
it's
and
basically,
electricity and
yes,
all these things. Yeah.
excellent. So if you understand economics in finance, that's what it
Yes.
means. 84 means it's it's a fixed cost. It's a fixed cost plus a variable cost gives you the entire, what is variable cost? The cost of producing the actual quantity, like item. Just say this factory is producing t-shirts, okay? So variable cost.
Mr. Does
So
this
because
mean
it's a,
when you have a graph, like when x equals 0, y equals 84?
yeah. So
Oh.
that basically means 84 means you still have to pay your workers. It's like your fixed cost, operation cost, as it is once said. But now we don't want to find this. I was just explaining what does this mean. Now, what is C prime Q? C prime Q is the derivative of this. Derivative of a constant is 0, so 0.16. 2 times 0.00, so it's going to be 2 times that will be negative 0.0012, right? Is that correct? I took this and multiplied by 2. I took away 1 from the power. And 3 times that, all of this with a 9 at the end. 0.12345, 6 the decimal place. Plus 0.00000009 Q squared. Right. I'm going to put 100 inside. Right? What does that represent? Give me 100. Substitute.
Wait,
Someone
wait, I'm
please
putting it
substitute
in
100.
the calculator. Wait.
Yeah. Please put it in the calculator and tell me what that value is.
It's 0.13.
0.13 cents. Right.
Yes,
0.13.
0.13, yes.
All right, so 0.13, this is like 13 cents to the dollar. Now, what they're saying, I will explain this, what this means. Compare C prime 100 with the cost of producing the 101st item. What is the cost of producing the 101st item? The actual cost of producing the 101st item. So I'm going to find this. I'm going to find C of 100. Someone please find C of 101.
It's 0.1306.
C of 101.
Yeah, 0.130609.
No, you're not substituting in here, sorry. You need to substitute into the original function, 84 plus, because I want to find C of 101. I need you to substitute, I need you to substitute 101 inside this function and then substitute 100 in that same function. Sorry, I'll just keep on going up and yeah, there's it here.
Ghazali, let
there
me
we are.
see.
You can see it now. So you're typing 84 plus 0.16 times 101 minus 0.
Mr. The cost of making the 101 would be 97.13.
97.138. And what is C of 100?
Wait, let me do it. $97.
97. Take the difference, the absolute difference between C101 minus C100.
Mr. The difference is the derivative, right?
Yes. What is this?
0.13. Because the derivative is the slope, so it represents the difference.
No. It's not because of that. Listen, that's what the derivative means. It's, you see, in application, when we do application, that's where you will understand what does the derivative, and when you substitute values, what does that mean? So find and interpret C prime 100. You have to say this is the cost of producing the 101st item. That's what it is basically. So remember what they said. So this is what the cost of producing an additional item. Okay, and see what I did. I found C101 and C100. Okay, if I make 100 units of t-shirts, okay, I'm going to be paying $97. But if I make 101 units of t-shirts, I'm going to pay $97.13. So it's just, what's the difference between these two? The
13
difference
cents.
represents the derivatives. Yeah, 13 cents. So we got the same answer. Okay. So what we did over here is more like the average gradient. Okay. And what we did over here was the instantaneous gradient at that instant. Okay.
So, Mister,
Mhm.
in the original function, when C equals 100, that means that's how much money you'd spend producing.
Yes.
And the derivative is how much each
For
item
100,
costs.
that's your total. Yes. What's the
Okay,
cost
I
of
understand.
producing the next item? Yes. Yeah. Okay. Are we good? Hello.
Yeah, we're
You
good.
understand, guys? Right. Excellent. Now, remember my today's lesson. See, I went into details of all this. My today's lesson was supposed to be on related rates. We can work with like 3 problems and little bit challenging problems, and we can work with that. Now, what are related rates? At least you know what a rate is. When we talk about rate, we are talking about time, okay, or some kind of change in volume with respect to time, and most of the time is with respect to time. So we're looking at related rates. Or sometimes we talk about how is the volume changing with respect to the radius, okay? Now, see, you have different types of functions. Example, remember in related rates, like if you're looking at a volume function, right? Volume is equal to volume of what? Example, volume of a cylinder, right? We got high r squared times height. Now, how do we model this problem? We model this problem. I'm just looking at a cylindrical tank here, right? It's like water being flowed into it, right? Filling water into a cylindrical tank, or we are opening the tap and we are releasing water. Or think of this as being a dam, right? Now, remember, this has some, it has a radius. I should have give you a cone rather. That would have made more sense. Okay, let me change this into a cone. No, it's fine. Let's keep it like this. Pi r squared times height. Now you can see as water fills into the tank, what's happening? So the water will fill into the tank at some rate, right? And the height will start rising at some rate, the height of the water level. See, the water level rises with some rate. So when you're filling water, when you're filling water into the tank, that's volume of water. So that is dV dt. The rate is dV dt. When the height is increasing or decreasing, that is dH dt. So these rates are in relation to each other. They are related. As a result, we call it related rates. So now look at this. Sometimes, remember, this is just a cylindrical thing. So the radius is kind of like constant. Okay, because you're not changing the radius because of the shape. But now when it is a cone, it's a different scenario. Okay, example, if it's an inverted cone like this, right? And in this case, the scenario is different. So now how can I change this volume function in the first scenario? I'm going to show you that now. See, this is the volume of this. So now we have to write both as a function in t. So you have to write v of t, volume with respect to time, is equal to pi r squared times h of t. So everything, the height is a function in time, the volume is a function in time, because remember the volume of water is also increasing as you are putting water into the tank, filling water into the tank. Now let's look at this scenario here. Now, if you're going to try to change the height, see, the radius keeps on changing. See there? Can you see? Radius at each water level. So you're going to have dH dt. You're going to have, for the radius keeps on changing. You're going to have dr dt. And you're going to have dV dt. You're going to have three different types of rates here, because the volume function is 1/3 pi r squared times height. So V is a function in time, R is a function in time, and H is also a function in time. So when you're trying to differentiate this, it's going to end up being product rule. So what you're going to do is you have to use implicit in all the cases, implicit differentiation. So I want you to differentiate this, right? Let's just say 1/3 pi r squared. So I want you to differentiate this. How are you going to differentiate this function here, volume? So I want you to differentiate volume, note.
Mr. Ghazali,
Yes, 1/3 pi r squared,
Mr. How is
times
R a
height.
function of time?
Because when you filling water into the cone. At each water level, the radius keeps on expanding. The radius is also changing. That's why I drew these circles here. The radius right at the
Oh.
top is the biggest. But now over here, it's not like a cylinder now. The radius is constant. It's the same circle you can fill. Over here, the circles keeps on changing. So the radius keeps on changing. Okay.
Okay, I see.
So now if I'm trying to find the derivative here, I'm going to say dv dt, or you say v prime. Let's just say v prime. V prime is equal to 1 over 3 pi. We'll just leave out. That's just a constant. Find the derivative of this. You're going to have a problem because the derivative of this is product rule. What's the derivative of this? 2r r prime. Leave the h. Plus, what's the derivative of h? H prime r squared. So now let's write this whole thing out. What is r prime? R prime is dr dt. It's a function in time. What is h prime? dh dt. And what is v prime? dv dt. Are we good, guys?
Yep.
Let's take an example. Now this is going to tickle your brains a bit because look at the type of problem that's represented here. A is being pumped into a spherical balloon, right? So that its volume increases at a rate of 100 cm cubed per second. How fast is the radius of the balloon increasing when the diameter is 50? Very limited information. First, what are they talking about? They're talking about A is being pumped into a spherical balloon. So what's volume of sphere? Volume of sphere is 4 over 3 pi r cubed. Are we good? Now, what are the rates that's given? We are given a rate which is dv dt. Volume increases at a rate of 100 cm cubed. So we are given v prime. What is v prime? 100. Okay, that is dv dt. Are we good? How fast is the radius of the balloon increasing when the diameter is 50? Now, after you differentiate, then you see the last part of the sentence is always at the end. So let me give you a picture of what's happening here. So you have a balloon.
We can calculate the volume.
No, we want the
As they
rate.
said,
That's why it's called relay.
Diameter is 50. That means the radius is 25.
Yeah, we know the radius
You
is 25.
substitute
That's
25
towards the
in.
end. No, you can't. We don't need a volume. We want how fast is the radius of the balloon increasing when the diameter is 50.
So you want dr dt.
So remember, yes. So basically what's happening is you have a balloon and it's expanding, okay? Because you're pumping air into the balloon, right? So the balloon expands to there. So initially the radius was there. Now the radius got bigger and bigger. So we want to know at radius 25. So remember, diameter of 50 means a radius is equal to 25. So at that instant, so we're going to find v prime. What is v prime? Find the derivative of this, 4 over 3 pi r cubed, 3 times 4 over 3 pi. Or write this and 4 over 3 pi. And find the derivative of 3r is 3r squared times r prime. Okay, what are you solving for? You are basically solving for r prime. That's why this whole related rates section is implicit differentiation. It's application of implicit. That's what related rates is. Now, remember the 3 and the 3 cancels out. dv dt, see, v prime is dv dt. That's 100. So we can fill in 100 here. On this side, we have 4 pi. What's r squared? R is 25, okay? And that's r prime. So what's r prime equal to? dr dt is 100 divided by 4 times 25 is also 100. So 100 and 100 cancels out. So 100 divided by 4 times pi times 25 times 25. See how I'm simplifying? Okay. So the 100 and the 4 and the 25 cancels out because 25 times 4 is 100. 100 and 100 cancels out. I got 1 over 25 pi. What is 1 over 25 pi approximately equal to? It's going to be centimeters per, remember this here is centimeters per second, the unit of measurement. Yes, guys, what's 1 over
0.01, 0.012.
0.012 centimeters per second. That's what's happening. Okay. That's how the radius is increasing every second as you are pumping air into the balloon. When you're pumping air into the balloon, there's volume of air that's going through, right? If the volume of air is going through every second, that's how much is increasing by. Are we good, guys? So that's what's just the
Mister,
first
in
example.
this case, it makes sense, but in this case, we were given a rate of 100 centimeters cubed, right?
Yes.
This, okay, so it's the rate, I understand that, but the volume in this case is in a cubic unit. Why did we have to differentiate it?
Because we are looking for the rate. How fast is the radius of the balloon
Mhm.
increasing? We want to know we want to find dr dt. You see this question over here?
Yeah, we need
This
R
question,
prime basically, right?
yeah, so we want to
The
find
same
r
thing as,
prime,
okay,
which is dr dt.
dr
The
dt.
question is how are you going to find dr dt without differentiating? You have to differentiate both
Oh,
sides.
okay, you have to
Okay.
differentiate both sides. Okay.
That's why it's called implicit differentiation with respect to time. So just do implicit.
Okay.
That's it. You do
Just do
implicit,
implicit, yeah.
problem solved. Yeah.
Okay.
It's basically application of implicit. That's what related rates. Guys, I'm gonna go on till 7 o'clock because I'm not done. I need to do more questions. I took too much time explaining all this. This is a nice example about the ladder and stuff. So let's work with this. A ladder 5 meters long rests against a vertical wall. So let me give you an example of what's happening here now. So there's your wall here, right? And there's a ladder. Let's draw it in a different color, right? So we have the ladder resting against the wall, right? It's exactly 5 meters. So let's try to chop off the rest piece. All right. So the ladder is 5 meters long. Now the thing is, because the ladder is 5 meters long, obviously it can't be shorter now. That's fixed. Are we good? Now see what's happening. If the bottom of the ladder slides away from the wall, what's happening? The bottom of the ladder is sliding away. The foot of the ladder is sliding away. Then obviously that part is going down, isn't? The top of the ladder is going down the wall because this ladder is fixed, is
Yes.
sliding away. So now we are dealing with two different rates, which is dx dt, and we are dealing with dy dt. Okay. So let's write a formula for this triangle. What is the formula for this triangle? We have to choose a variable. We have to choose x and y. So this is x and this is y. If the bottom of the ladder slides away from the wall at a rate of 1 meters per second, so remember, 1 meters per second is dx dt, basically x prime, right? X prime is given, which is 1 meters per second. How fast is the top of the ladder sliding down the wall? So we want to find dy dt, or we will want to find y prime. That's what our question is. When the bottom of the ladder is 3 meters from the wall. Okay, so we need to write an equation that models this scenario. Before, the equation that modeled the spherical balloon was 4 over 3 pi r cube. We're talking about volume. Now we are dealing with triangle. What is the equation that models a triangle? Pythagoras. X squared plus y squared equals 25. So start off with that equation. X squared plus y squared is equal to 25. Do we implicit on this? Let's implicit differentiate this. If you implicit differentiate this, you're going to get 2x times x prime plus 2y times y prime is equal to 0. Because x and y are both functions in time. Are we good, guys? Now, read the last part of the story here. If you're reading the last part of the story, see what it says. How fast is the top of the ladder sliding down the wall? So that's your question. So I need to draw another triangle now and fix it at a certain point. So now, when I draw another triangle, see what's happening now. What he's saying is that the ladder is still 5 meters. How fast is the top of the ladder sliding down the wall when the bottom of the ladder is 3 meters from the wall? So the bottom of the ladder is 3 meters from the wall. That's a 3, 4, 5 triangle. Right, so the y value is 4 here. The x value is 3 here. Okay? We still need to find the rates. So in other words, we need to find y prime. So let's fill in all the details now. 2 times x. So let's cancel out the 2's, okay? The 2 and the 2 can cancel out. How? Because we're dividing. So let's solve for y prime. So we're going to say y prime is equal to take the x times x prime over negative x times x prime and divided by y. So what is y prime? dy dt. So negative, what is x? X is 3. What is x prime? 1. There's the x prime, which is 1. What is y? Y is 4. So what is dy dt? Negative 0.75 meters per second. So because it's sliding down the wall, right, it's negative. Are we good, guys? Does this make sense?
Yeah.
Yes, Mr.
It's related rates. You have to do implicit. Next question.
Mr. Is this still implicit even though we're plugging in values that we figured out and things that were given in the question? Is it still implicit even though like we're dealing with
What?
dy dt and dx dt, but are we it's still implicit?
Yeah, what I'm saying is when you are differentiating, because both are functions in time, you have to implicitly differentiate both.
Okay.
It's not a function in x, both of them. X, what is x? X is x of t. What is y? Y is y of t.
Y of
So
t,
you have to
yeah.
differentiate. Yes, you have to differentiate
Okay.
both.
Okay.
Because
Mr.
both of them are, yes.
You answered
Guys,
this
I'm gonna do
one.
one more. I'm gonna do one more question and then I'm going to end off and then we can, I
Mr.
can
So
take some
basically
questions.
here, in the question, dx over dy, it's 1, right? I mean, dx over dt, the value of dx over dt is 1, right?
Yeah. They told us. We want to know how fast is the top of the ladder sliding down the wall. So we want to find dy dt. Now I want to do one
Okay,
difficult
yes.
I want to do a difficult one with trigonometry now. I got more questions here, but I'll put it in the homework, right? So because I just did 1 and 2. Let's look at this one. All right, so a man walks along a straight path at a speed of 1 meters per second. So he's walking straight, right? So let's just say he's walking in this direction. Right? So you are right, so he's walking in this direction. Let's see. He's got a speed there, right? So let's just say this is x direction he's walking in, right? So this is the direction, so let's just call it x. A spotlight is located on the ground 6 meters from the path and is kept focused on the man. A spotlight is located on the ground 6 meters from the path and is kept focused on the man. So let's just say this person is here, all right? And there's some kind of a spotlight on him, 6 meters from the path. At what rate is the spotlight rotating when the man is 4.5 meters from the point on the path closest to the light? Okay, let's just say
Spotlight
there's a
mean?
okay, not towards the end. We need to draw a diagram for this. You have to draw a diagram to make sense of this. Don't worry about the last part. Worry about this. A spotlight is located on the ground, right? So this is the horizontal plane, so he's on the ground. So there's some kind of a spotlight on him. Okay, and let's just say the light is here. Let's just say the light is over here somewhere. Straight path at a speed of 1 meters per second. Okay, so then, so see where the man started. A man walks along the straight path at a speed and is located 6 meters from the path. So there's a path over here he's going to take, right? So it's 6 meters here, right? And there's a spotlight over here on him. So you're doing it something like this, right? There's a spotlight. So as he's walking, the spotlight is on him. Are we good? Does it make sense?
Wait,
Yes.
mister, isn't it 6 meters like from the path from where he is?
Yeah, that's what I'm
It's
confused
6
about. It's
meters
supposed to be
from the
6
path.
meters from where he is, not 6 meters down.
But we don't know where he is exactly. Just
Oh,
say
okay.
because
So
he's
then, yeah, then that's fine.
he's moving.
It's
He's
6 meters
moving.
from that path. Yes. Yes.
He's
Okay.
moving because it's meters per second, right?
Mm-mm.
Now, obviously, we can call this distance x, right? We can call this 6, and we got a theta angle over here. At what rate is the spotlight rotating? So obviously, if this person was over here, if this man was here, right? The spotlight would have been like this on him like that, okay? So now you can see the spotlight is rotating as he's moving away from the path. The angle is getting bigger and bigger. So that's the rate of change we want to find. Are we good, guys? Make sense?
So we're looking, mister, we're looking for d theta dt.
Yeah. So kind of,
Okay.
sorry, I just drew this incorrectly. This should have been like 90-degree angle, okay? Because it's on the floor,
Ah.
it's on the ground.
On the ground. Okay.
Yeah, so we're looking for at what rate. So what can we do with this now? Can we use a theta angle over here? Let me draw this diagram properly now because we kind of have it. Right, so let's draw this diagram. I could have drew more angles here. Remember this many types of triangles, but all of them are right angles. Okay, so the path that the man is taking is x, right? And he's 6 meters away from the path initially. So that is 6 meters. So we got opposite adjacent, right? So that's tan theta. What's tan theta equals to? X over 6. There's a right triangle here. There's theta angle, right? That's opposite. This is adjacent. X is a function in time and theta is a function in time. So the first part of the statement is modeled by this equation. Okay. Now let's look at the given information that is given. What are the given information? So what we are given over here, speed of 1 meters per second. So that's dx dt. In other words, x prime is dx dt. That is given 1 meters per second. What else? A spotlight is located on the ground 6 meters from the path. So that's already there in the story. At what rate is the spotlight rotating? So we want to find d theta dt. In other words, we want to find theta prime. Okay, guys? When the man is 4.5 meters from the point on the path, that's easy now. You can just put 4.5 and that is still obviously that is not changing. That is fixed at 6 meters. Now let's find the derivative here. What's the derivative of tan?
Sec squared theta.
Sec
Right.
squared theta, good.
Okay.
And then the derivative of theta, how are you gonna find theta prime?
D theta
It's
dt.
implicit.
Or it's implicit.
Theta
Yeah.
prime.
Okay. Yes.
Plus 1/6 derivative of x, x prime. Are you good? Make sense?
Yes.
Right. Now, look at this story here now. I'm going to draw the same diagram because we need to fill in what is sec squared theta. So I need to draw the same diagram here.
Mr. The blue guy is the thing where it says it's 4.5 meters away, right?
No, it can be, remember this person is moving. Because he is moving in that path, horizontal path, I just moved this person from blue to purple to tell you that the light focus is gone bigger now. The
So
angle is gone bigger
basically,
now.
the derivative that you obtained in the first thing, which is sec theta, this is the thing for the first part where it says the speed of 1 and he's located off the ground at 6 meters, right?
No. What I'm substituting now is the second diagram with all the information at the end. At what rate is the spotlight rotating when the man is 4.5 meters from the
So
point?
4.5 meters means you have dx over dt, right?
No, 4.5 meters mean it's not, it's a distance. 4.5
It's
meters
just
is
x.
x.
Yeah.
Yeah.
It's just x. Because
Ah,
x prime is given. It's 1.
And this
so
is
you
this is
said,
already 6.
okay.
This is 6, okay? And what's the hypotenuse? You can use Pythagoras to find the hypotenuse now. Can someone please find it? Square root of 6 squared plus 4.5 squared. Give me the answer in the what you call. You can give me the answer in decimal points or whatever.
7.5.
You can use 7.5. Okay. Now, what is sec squared? From this diagram, remember theta is here. Sec is hypotenuse over adjacent. So 7.5 over 6, right?
Yes.
Squared. That is sec squared theta. This part is sorted out, right? We want to find theta prime. So that's d theta dr dt equals 1/6. What is x prime? X prime is just 1. So now problem solved. Take 1/6 and divide it by 7.5. So basically taking 1/6 and dividing it by 7.5 squared over 6 is the same thing as saying multiplying by 6 squared over 7.5 squared.
You'd get 8 over 75.
D theta dt is
8 over 75, Asadi.
give me that in decimal point.
0.106666666667.
Okay, just 0.107. Khalas. What? What? Radians
Radians.
per second.
Radians per
Convert this to degrees. Convert this to degrees.
Okay, tan.
So 0.107 times pi over 180.
Times pi.
Per second.
Mister, I
This
got
is it.
1.86 times 10 to the power of -3.
You're telling me the angle is so small.
Mr. I think it's in I think his is in degrees.
No, this
One
is
sec.
not in degrees. This is in radians. What we calculated was in radians. 0.107 radians.
Oh, okay.
Oh,
No,
wait,
it's the
wait,
same
wait, wait.
thing.
No. It's to sorry, to calculate in to calculate from radians to degrees, multiply by 180 and
Multiply by
divided by
180
pi.
divided by pi.
Yeah,
Yes.
it's the other way around. Sorry,
0.
watch. Times 180.
Yeah, you got 6.13.
Yeah, I
this
got
makes sense.
19.26. What?
Huh?
Oh, divide by
Wait,
pi. Sorry. Divide by pi. Yeah, 6.13. Oops.
So it's 6.13 degrees per second.
Yes.
Yeah, so 6.13 degrees per second. So that's how fast the light is rotating. It's like football players, man. You know, when you have those light and or the person holding the camera and he's 6 meters away, how fast is he rotating the camera focused
it's
on the
that way.
man? as in
Yeah,
moving.
okay.
So it's things like that. So this is purely application. That's what related rates are. All the variables are always functions in time. You can see every single variable I use here was a function in time. Unlike implicit, in implicit differentiation, you have an equation in x and y. Just y is a function in x. That's it. You only have to implicitly differentiate
بس العربي
y. Yeah, so guys, we're gonna end off now. All right, so 1 second, let me just end off the recording.